if we succeed either on purpose or even accidentally to bring conscious AI into existence, that brings a number of very severe dangers. Like the first danger is that AI that is conscious may have powers and capabilities that we would find very hard to control. And these boil down to the idea that conscious AI won't just have the interests and motivations that we humans give it. It will have its own interests in virtue of its own experiences. That's one danger. The second danger is a little more disquieting. It's that as soon as something has consciousness, has the capability of experiencing things, it has potentially the capability to suffer. It becomes a moral and ethical subject. And if we've created it, we have a moral and ethical responsibility towards it.
What's up, everybody? From Nautilus, I'm Brian Gallagher, and you're watching Behind the Scenes. Today I'm speaking with Anil Seth. Anil is a cognitive and computational neuroscientist at the University of Sussex in England. His intellectual mission is advancing the science of consciousness. He co-directs the Sackler Center for Consciousness Science and the Canadian Institute for Advanced Research Program on Brain, Mind, and Consciousness. He's also the editor-in-chief of the journal Neuroscience of Consciousness, and the author of the recent book Being You, A New Science of Consciousness, which was named Book of the Year by outlets like The Economist, Bloomberg Business, and The Guardian. His 2017 TED Talk about his research has over 13 million views. His recent story in Nautilus was Why Conscious AI is a Bad Idea. Our minds haven't evolved to deal with machines we believe have consciousness. Anil, thanks so much for joining us.
It's a pleasure to be here. Thanks for the invitation.
All right, to start off, could you summarize your intellectual and academic background a bit and tell us how you came to focus your research specifically on consciousness?
I've leapt around quite a lot, really. So I've always been interested in consciousness. I remember as a kid, even though I didn't think of it that way, I was wondering, why am I me and not somebody else? Where was I before I was born? What happens when I die? And over the years, that became a deeper interest in how is it that this incredibly complicated biological machine inside my head can generate conscious experience. Why are we more than objects? Why do we have this almost everyday, apparently miraculous property of being aware of our surroundings and of ourself? But there wasn't really a degree course in consciousness research. So I ended up starting off with physics. I thought physics has the answers to everything, and physics changed into experimental psychology, which I thought would get me more directly there. And then there was a very long diversion through computer science and AI. So my PhD, in fact, is in artificial intelligence. And only after that, I ended up as a postdoc coming to the US and to San Diego, actually, which is one of the few places about 20 years ago where there was a hotbed of activity about consciousness specifically. Because now consciousness, well, at that time, consciousness was beginning to be part of mind and brain sciences again. You could get jobs doing it. You could even get grant funding doing it. And if you were lucky. So really for the best 20 years or so, consciousness has been my focus. And then in 2007, I moved back to the University of Sussex and set up a research center to try to shed more light on the biological basis of consciousness and its interactions with other fields like artificial intelligence, like psychiatry, neurology, and so on.
All right. So in your latest piece, Why Conscious AI is a Bad Idea, we kind of learned that, perhaps more consciousness isn't more the merrier. Could you give us a brief summary of your story for viewers who haven't read it yet?
Sure. As we all know, advances in AI have been pretty astounding lately, and they take by surprise even people within the area. And myself and my colleagues who are much more actively involved in AI. I mean, I'm kind of on the interface between neuroscience and AI. And there have been rightly a number of concerns about this rapid acceleration in AI capability. Things like the potential for misinformation and disinformation, I think, very important, and lots of people making very sensible noises about increased regulation and so on. But in parallel with this debate about current AI's capabilities, there's this other debate about machine consciousness. Will there come a point at which artificial intelligence isn't merely smart, but also sentient? Instead of just coming up with interesting and intelligent answers, does it actually feel like anything to be an AI? And the debate here has been, in my opinion, it's been a little more confused and less helpful than the rest of the debate about the acceleration in AI. So I was really motivated, given my kind of background really on the interface of both consciousness research and AI, to try to sharpen some views about this. And I think there are two good reasons. And the reasons really are associated with both the likelihood that AI will be conscious and the risks involved. Some AI companies are even trying to build conscious AI. They set it as an explicit goal, which is, I think, as the title says, a very, very bad idea indeed. So the piece makes a few connected points. The first point is that consciousness and intelligence are really very different things. There's this assumption in and around the AI community that as AI gets smarter, then at some point, maybe the point of general AI, the point in which AI becomes as intelligent as a human being, that's the point at which suddenly the lights come on for the system and it's aware. It doesn't just do things, it feels things. But intelligence, broadly defined, is about doing the right thing at the right time, having goals, achieving goals in a flexible way. But consciousness is all about subjective experience, raw experience, feelings, things like pain, pleasure, and then experiences of the world around us and of the self within it. Now, being intelligent, as we humans like to think we are, might give us different ways of being conscious. And there may be some forms of intelligence that require consciousness in humans and other animals. But fundamentally, they're different things. And this assumption that consciousness just comes along for the ride I think, is mistaken. So that's one point I wanted to make. So it's not just going to happen. But the other point is that there are some people who say, okay, let's try to build systems that are conscious, without assuming it's just going to happen anyway. Let's take some of our theories of consciousness and try and build machines that actually express consciousness. I think this should not be happening. I think that there should be regulations that basically say, let's not do that. And the reason here is there's a lot of uncertainty. We don't know how to build a conscious machine. There's no consensus about what the sufficient mechanisms are. There are many theories. They're all interesting. There's no agreement about which is right. I have my own theory in the book that it's very coupled with being alive. So you won't get conscious machines until you get living machines. But I might be wrong. And another theory might be right, in which case consciousness in AI is much closer than we might think. So given this uncertainty, we should be very, very cautious indeed. And this brings me to the risks, which I'll cover quickly. If we succeed either on purpose or even accidentally to bring conscious AI into existence, that brings a number of very severe dangers. Like the first danger is that AI that is conscious may have powers and capabilities that we would find very hard to control. And these boil down to the idea that conscious AI won't just have the interests and motivations that we humans give it. It will have its own interests in virtue of its own experiences. That's one danger. The second danger is a little more disquieting. It's that as soon as something has consciousness, has the capability of experiencing things, it has potentially the capability to suffer. It becomes a moral and ethical subject. And if we've created it, we have a moral and ethical responsibility towards it. And the issue here is AI is maybe very easily just replicated we get a flick of a mouse button, we can create conscious AI in server farms all over the planet and potentially introduce vast new potential for suffering on a ethically catastrophic scale. So there are two risks about actually conscious AI, and they may seem kind of outlandish and far away, but the worry is that we just don't know what it would take to build conscious AI, and we don't know for sure how to avoid doing it. And these risks are so severe that they should be borne in mind, even if they seem very distant, very remote. But there's another risk which I don't think has been focused on very much, and I think is here already. which is the danger posed by AI systems that are not conscious, or we have no good reason to believe they are, but they give us the impenetrable, detailed, strong, vivid impression that they are conscious. I mean, chatbots like GPT-4 almost do this already. They engage in fluent dialogue with us. And it's very, very difficult to avoid projecting some kind of mind behind the words that we read. And I think this is potentially also very disruptive for society. We're not quite there yet. Existing large language models, chatbots can still be caught out. But we humans, we have a deeply anthropomorphic tendency to project consciousness and mind into things on the basis of relatively superficial similarity. So as AI gets more fluent, gets harder to catch out, it'll become more and more difficult for us to avoid just interacting with these things as if they are conscious, even though they are not. And why is this disruptive? I think it's problematic. Firstly, because we maybe we'll make a lot of mistakes about our predictions, how they might behave. If we think something is conscious, then we might assume that it will behave in a particular way because we are conscious. So we might make catastrophically bad predictions about how these systems will behave, and that could be problematic. And the other problem is that it might contort the kind of ethics we have. If we really feel that something is conscious, then we might start to care about it, care about what it says, care about its welfare in a way that might prevent us from caring about other things that are conscious but just don't speak to us in the same way, maybe other kinds of non-human animals and so on. So science fiction series like Westworld have addressed this, I think, in a way that is not very reassuring, where they have robots in Westworld that seem to be conscious but probably are not. And the people interacting with them end up learning to treat these systems as if they're some slaves of some kind. And that's not a very healthy position for our psychologies to be in. So there are two different kinds of worries. Generating actual machine consciousness, which is not the same thing as intelligence, seems very remote, but might not be. That would be damaging because of a certain set of consequences and risk and ethical catastrophe. And then a more near-term set of worries about machines that merely seem conscious, and those are coming pretty soon. We should be careful to consider both kinds of worries and not conflate them.
So is that kind of commitment to not building conscious machines in tension at all with your aim of understanding consciousness? Because the roboticist Alan Winfield thinks building conscious machines, kind of starting with simulation-based internal models and artificial theory of mind, will be key to solving consciousness. And he cited Richard Feynman's dictum that if you can't build it, you don't understand it. What do you make of that?
I think there is a tension. I think Alan has a point, and it's something I struggle with a little bit. And it sort of depends on what you think is going to create conscious AI. So for me, my particular perspective on it is that consciousness is very closely tied up with being alive. So, I think simulating the brain on computers as we have them now is not the same as building or instantiating a conscious system. But I might be wrong. So there's a certain risk to that in fact simulating something is the same as instantiating, is the same as generating it. In which case, then I'm not being as cautious as I think I am. But, on the other hand, of course, unless we understand how consciousness happens in biological brains and bodies, then we'll not be on firm ground at all in trying to make inferences about when other systems are conscious, whether they're machine learning systems, artificial intelligence systems, other animals, or newborn babies, or anything. Will be on very, very shaky ground. So I do think there's a need for research into consciousness. All I'm saying is that there shouldn't be this kind of gung-ho goal. Let's try to just build something that actually is conscious because it's kind of cool. I mean, that should just not be happening. And research in this area, there should be some kind of ethical regulation about what's worth doing, what are the pros and cons, what are the risks, what are the rewards, just as there are in other areas of research.
Why do you think that consciousness isn't some kind of complicated algorithm that neurons implement?
I think this common assumption that it is, which is an assumption often called functionalism in philosophy, uh, is a really big assumption to make. It's, some things in the world, when you simulate them, you run an algorithm, you actually get the thing. So an algorithm that plays chess, let's say, is actually playing chess. That's fine. But there are other things for which an algorithmic simulation is just and always will be a simulation. So think of something like a computer simulation of a weather system. And we can simulate a weather system in as much detail as we like, but nobody would ever expect it to get wet or windy inside a computer simulation of a hurricane, right? It's just a simulation. And the question is consciousness more like chess or is it more like the weather? And
Mm.
the common idea that consciousness is just an algorithm that runs on the wetware of the brain assumes that consciousness is more like chess and less like the weather. But for me, there's very little reason why this should be the case. And I think it stems from this historical idea we're kind of saddled with still, that the brain is a kind of computer and the mind and the conscious mind is a program running on the computer of the brain. But the more you look into the brain, the less like a computer it actually appears to be. There's no, whereas in a computer, you've got a sharp distinction between the substrate, the silicon hardware, and the software that runs on it. That's why computers are useful. You can have the same computer, it can run a billion different programs. But in the brain, it's not like that at all. There's no sharp distinction between the mindware and the wetware. Even a single neuron, every time it fires, its connections strengths change. And a single neuron tries to sort of persist over time as well. It's a very complicated object. And then, of course, there are chemicals swirling around. Um, so it's just not clear to me that consciousness is something that you can abstract away from the stuff that brains and bodies are made out of and just implement it in the pristine circuits of some other kind of system.
I mean, based on my understanding, it seems to be a little bit in tension with how you've talked about sort of our conscious experience being a kind of hallucination. Is the brain not sort of simulating the world out there, and sort of generating, a world that we live in and kind of predicting what's out there? And I mean, it sounds like a kind of simulated reality that the brain is creating.
I mean, I don't think it's an intention. I don't think there's a tension here at all. Actually, I think the argument, the story that I tell in my book, Being You, is kind of how the first idea that the brain creates this controlled hallucination, which we experience as reality, how that ultimately um, has its roots in the biology of the body in a very substrate dependent manner. So the first idea is, it seems as excuse me. So the first idea is that it seems to us that we see the world as it is in a kind of mind independent way. We open our eyes and there it is, there's the world. Uh, the idea that I explore in the book and in my research as well is that this is not what's happening, and that in fact the brain is always making predictions about what's out there in the world or in here in the body, and using sensory signals to update those predictions. And what we consciously experience is not a readout of the sensory data in a kind of outside in direction. It's the predictions themselves. It's the brain's best guess of what's going on. I don't think this necessarily means it's a simulation of objective reality. I just think it means that the brain has some kind of model. It has a generative model of the causes of its sensory signals, and that really constitutes what we experience. But it also has the same process about the body itself. If you think about what brains are for, evolutionarily speaking and developmentally speaking, they're not for doing neuroscience or playing chess or whatever. They're for keeping the body alive. And the brain has to control and regulate things like blood pressure and heartbeat and gastric tension and all these physiological processes to make sure that we stay within these very tight bounds that are compatible with staying alive for complex organisms like us. And the argument in the book is that this entails that the brain is or has a predictive model of its own body, because prediction is very good for regulation. and that this goes down all the way into the depths of the physiology, and even single cells self-regulate in a very interesting way. So the substrate dependency is built in from the ground up here, and then the ways in which we experience the world are really elaborations of this fundamental mechanism of predictive regulation of the body. So in the book, I say that, that we experience the world around us and ourselves within it through, and because of our living bodies. And there's a common process here, which is the brain making predictions and updating those predictions using sensory data.
Why does consciousness have to be an embodied phenomenon when we can have experiences of lacking a body?
I think that just shows that our experiences of disembodiment, which you're right, they can happen. People can have out of body experiences, they can have experiences of things like ego dissolution and so on. It shows that how things appear in our experience is not always, if ever, an accurate reflection of how they actually are. Now, our experience of what our body is itself a kind of perception. Now, there are many experiments that show that it's quite easy to manipulate people's experiences of what their body is and where it is, and what object in the world is part of the body or not. So the experience of the body is different from the body itself. And it may be, and I think it probably is true, that in any single moment, all you need to have a particular experience is the brain being in a particular state. I think if the brain is in a particular state, you have a corresponding experience. But to get the brain into a condition that it can have those kinds of states corresponding to conscious experiences, my suspicion is there needs to have at least been a history of embodiment.
Mm.
A brain that's not had any interaction with a body or a world, that just doesn't. It might be conscious, but it would not be conscious of anything at all. And here I think there's actually another important ethical issue. There's been a lot of fuss about AI. We've been talking about that, but there's another technology, which is the technology of brain organoids. These are
Mm.
clusters of basically of neurons that are derived from human stem cells that develop in a dish, and they don't really do much. They don't look very impressive. They certainly don't write poetry as chatbots can do. So we look at these and we're tempted to think, well, there's nothing ethically to worry about here. But for me, I'm much more concerned about the prospects of synthetic consciousness in brain organoids than I am in the next iteration of chatbots, because these organoids, they're made out of the same stuff.
Mm.
Sure, they don't have bodies, so that might be a deal breaker, but still, they're much closer to us in one critical sense, which is they're made out of the same material.
So that brings me back to the point about whether the brain is implementing some kind of algorithm to produce this. Because would you say that some processes or some parts of the brain are unconscious? I mean, the brain's doing a lot of stuff that we're not conscious of. So that would seem to imply that there is something in particular that the brain is doing in one part of its, information processing that leads to conscious experience. Um, so it, might it be the case that, brain organoids, even though they're made of the same stuff, maybe they're not functioning in a way that would produce consciousness, just like we're not conscious of everything that's happening in our brains?
That may be, but I'm still suspicious. Like, we're so used to using terms like information processing when we speak about brain, it just comes so naturally. But again, I think that's smuggling in so many assumptions about what brains are and how they work. It depends. What do you mean by information? What do you mean by processing? In Claude Shannon's definition of information, it's really something that is relative to an observer. It's something that we might apply when looking at a brain to interpret its activity. So to say the brain processes information is to make all kinds of assumptions about the nature of what's important that are just not clear. But
Mm.
anyway, to move on from that, you're absolutely right that there's lots of stuff that goes on in the brain that doesn't seem to be directly implicated in consciousness. Like, everything is indirectly implicated. But if we look at where the tightest relationships are between brain activity and consciousness, we can rule out large parts of the brain. We can rule out the cerebellum. The cerebellum at the back of the brain has 3/4 of all our neurons. And that doesn't seem to be directly implicated in consciousness at all. So certainly, there are some things that biological brains do that wouldn't by themselves result in consciousness. So if you just had a cerebellum by itself, my guess is it would not support any conscious experiences. Now, I think the right way to think about that is that just being made of neurons and having this kind of biological substrate, well, that might be necessary for consciousness, but it's certainly not sufficient. So it has to be that stuff also doing the right thing. And if you look at the landscape of the most prominent theories of consciousness that are out there, that's the level that they're talking about. It's different kinds of things that can be described using algorithms, yes, but they are different ways of identifying, well, what is the critical thing that makes brain activity conscious versus unconscious.
How do you think about what the adaptive value might have been of having conscious experiences? Like, do you think that insects or plants have a possibility of being conscious?
This is a huge problem, and they're very connected. So there's two connected problems here. One is like, what is the function of consciousness? It's famously often said that nothing in biology makes sense except in the light of evolution. And that poses the question is, why did evolution provide us with conscious experiences, and did it provide all organisms with conscious experiences? And the connected question is, how will we ever know? How can we be? Can we develop a test, to decide whether a plant has experience or not, or indeed whether an organoid or an AI system has conscious experiences? And these are connected because if you understand the function, then we've got a way in to apply some tests, at least in some cases. Now, there are some people, certainly in philosophy, that argue that consciousness has no function at all. It's just there, but it doesn't play any role in an organism's behavior. I find this very, very difficult to grasp. And it's such a central phenomenon of our lives that it's a very, to make that claim that it has no function, I think it's quite an extraordinary claim, would require a great deal of a stronger argument for me. It seems that conscious experiences in the way they are, and if you just look at the character of conscious experience, it's incredibly functionally useful. A conscious experience, typically for us humans, it brings together a large amount of information about the world from many different modalities at once, sight, sound, touch, whatever, taste, in a single unified scene that immediately makes apparent what the organism should do next. We experience the world in relation to our body and in relation to our sort of prospects for surviving over the long term, for doing the right thing. We experience opportunities for action. We experience emotions along with our scenes. Things are good or bad, or going to be good or bad in the future. So for me, that's the primary function of consciousness, to bring together a large amount of information in a way that really guides the motivated behavior of the organism, that maximizes its chances of staying alive. And if systems don't face that kind of problem, like a plant, I mean, plants are amazing, which sounds a very trite thing to say, but plants, they are more interesting than I think many people think. If you slow time down and look at plant behavior over a slower timescale, they behave. They don't just waft around in the wind. Many plants appear to have goals. They appear to engage in intentional action, follow the sun around and so on, exchange nutrients and so on. But they don't have nervous systems of any sort of, certainly not of the kind that bear comparison to humans. They have simple reactive systems for plants that, like Venus flytraps and so on. But do they really face the same problem of integrating large amounts of information in a way to support sort of rapid online flexible behavior? That doesn't seem clear to me that they do. And I think in terms of inferring where consciousness resides in the world beyond the human, it's really very difficult. And we have to be very cautious and extrapolate slowly. We know we are conscious. If we look across all mammals, you see the same brain mechanisms that are implicated in human consciousness. If you go further afield than that to insects and say fish, it becomes more controversial and more difficult to say for sure. But I don't think the problem is insoluble. I think there's already been progress. By understanding more about the human case, we can make better generalizations. If we begin to understand, okay, it's not just having this part of the brain, but it's this way in which brain regions speak to each other that's important. That gives us then something which we can look for in other animals that may have quite different brains to our own. But then when you get to plants, much more difficult.
So, could you imagine a machine being conscious and yet not being capable of suffering or dissatisfaction? And something like this is true of some people who can't feel pain, for instance.
I think this is a really fascinating question. It's tempting to think, and I think most people assume when they think about conscious AI, we think about the science fiction movies like Ex Machina or Terminator or something. We think about artificial consciousness that's very similar to ours. But it might be that the different things that come together in a seamless way in human consciousness might be dissociable. So it might be possible, if we have a sufficiently refined understanding of biological consciousness, to build systems that have some aspects of consciousness but not others. So perhaps systems that indeed don't have emotional responses but still have the ability to pull together large amounts of information. That might be very useful, or the ability to reflect on what they know, which is again something AI systems currently are not very good at. It might even be possible to build systems that just do not have their own intrinsic goals. One of my colleagues, Yoshua Bengio, an AI pioneer in Canada, has suggested that a good design principle for AI might be a kind of oracle. So systems that are developed to tell us the truth and to give us as much useful information as possible, but they don't have their own goals. I think that's a really interesting prospect, and that's why I think caution is really the watchword here, because we're just beginning to explore this territory. And firstly, we need to know how all these aspects of consciousness go together in the cases where we know consciousness exists, so that if we are going to move towards building systems that are positive for humanity, positive to society, that we do so in an informed way and that recognize the things that we might want to build in and the things that we definitely do not want to build in.
Are you aware of any theory or framework of consciousness, say like integrated information theory, that would suggest that large language models like GPT-4 are conscious to any degree?
um to my understanding, I know the philosopher David Chalmers has talked about this quite a lot recently. The different theories of consciousness that we have all make quite different claims about what it would take to be conscious. Integrated information theory, I think, is one of the more interesting theories in this regard, because it makes very strong claims about what's sufficient. Any system that integrates information in a particular way will be conscious to some extent. It's not to do with information processing, interestingly, here. Integrated information theory is all about the actual cause effect physical structure of a system and the dynamics that run on it. So it's not substrate independent. It's not a question of algorithm. It's also a question of structure. Large language models, I think, have the kind of architecture where most theories would say, no, there's not really any consciousness happening. They are, you can probably think of them more in terms of large cerebellums. I mean, they're trained on a lot of data, but without the kind of recurrency and global information sharing that some theories of consciousness emphasize.
Hmm. Can you tell us about any more interesting tidbits or details or ideas you thought about mentioning in this piece, but for whatever reason you didn't end up including in this Nautilus story about caution regarding AI?
I guess there's just one anecdote. One thing that came to my mind that I was quite surprised that it came to my mind. I was, for various reasons, rereading Frankenstein. In fact, I was reading Frankenstein for the first time, this classic Gothic novel about scientific hubris and its consequences. And I realized I'd never actually read the original book. I thought I had because I'm so familiar with the movies and the archetypes that we have. And the book is so
Mm,
much more subtle. Now, the archetype we have is of a mad scientist and of a kind of towering, lumbering, dull oaf of a monster. And in the book, firstly, the scientist is not mad at all. He's hubristic, but he's incredibly intellectually agile and curious and humane. And the creature is not at all a lumbering oaf. It's incredibly intelligent and athletic and quick of mind, fleet of foot. And so this, I think, to me, it gave Frankenstein a new relevance to today. That when we think about the new technology that we're creating, whether they're AI systems or organoids or whatever they might be, you don't have to be a mad scientist to be a dangerous person in this context. We can have
mm.
the most pure of aims, trying to think that we're doing the best thing, and the unintended consequences of what we're doing could still be dramatically dangerous. And the other thing that came to mind when reading Frankenstein was it's always talked about as a story of what happens when a scientist gave life to an unliving, inanimate object. It's a story about giving the spark of life to something. But actually, if you think about Frankenstein, what really mattered was not the giving of life, but the fact that the creature could feel, that it was
Mm.
conscious. That's why Frankenstein's creature ended up with its motives for revenge after being excluded and and just ostracized from society. It wasn't a question of life; it was a question of consciousness.
Right, and that links up very much with a lot of the sort of dystopian tales we have about AI, where they become conscious and then become aware of their lower status and want to seek revenge for not being treated with the respect they believe they're due. Um,
Yeah, here I
yeah.
think, yeah, we don't want to get too far drawn into the science fiction trope, but it was just interesting to me that it was much more relevant to this debate than I thought it would be. It's the endowment of. I mean, of course, we build living systems in the lab now. There is such a thing as synthetic life, and there is artificial life, and there's some ethical challenges there too. But I think these ethical challenges get much more dramatic as soon as we build systems that are not only alive but also conscious.
What are you working on at the moment? You got any interesting studies in the works or papers coming out?
Working on a few things at the moment. So one of them is actually quite connected to what we've talked about, which is trying to use computational models to understand more about different kinds of visual experience. So here we're looking at different kinds of hallucinations that might happen in psychosis, that might happen in psychedelics, that can happen in various neurological conditions like Parkinson's disease. Um, and these hallucinations all have different characters. Some are simple, some are complex, some are spontaneous, some seem to emerge out of the environment. And we're trying to understand the computational mechanisms that underpin these different kinds of experience, both to shed light on these conditions, but also more generally to try, therefore, to understand more about normal, non hallucinatory experience. So, in a sense, I'm not trying to build a conscious machine here, but I am using computational models to understand more about human consciousness.
Hmm.
That's one thing. The other project I wanted to briefly mention is one of the consequences of this view that perception is a kind of brain-based prediction is that, well, we all have different brains, so we're all going to experience things slightly differently, even if we share the same objective reality. We all differ on the outside in terms of skin color and height and shape and so on. So we're all going to differ on the inside too. But we don't know very much about this hidden landscape of perceptual or inner diversity. There was that example of the dress a few years ago that half the world saw one way and half saw another way. But it's not just the dress. I mean, I think we all experience things in our own distinctive way all the time. So I have a project called the Perception Census, which is a very large scale online citizen science project to try and characterize how we differ in our perceptual experiences across many different domains like vision, color, time, emotion, sound, music, and lots of things at once. And it's very ambitious. We've already got about 25,000 people have taken part from 100 countries. And there are about 50 different dimensions of perception we're looking at within this study. And the objective here is to see if there's some kind of underlying latent space, sort of perceptual personalities, if you like, that explain how individual differences in perception might go together when we look at different kinds of perception. So that's
As well
kind
as
of uncharted territory. And we're
yeah,
still collecting data for it. So there's a website for it which you can easily find on my webpage. So if anybody watching this wants to get the warm glow of helping contribute to this effort, then, and you also learn about perception and about your own way of perceiving the world, then have a go at the Perception Census. And we designed it to be fun and engaging and informative as well as useful.
it reminds me of this example that the philosopher of perception Masvita Chirmuta brought up to me about how I think it was either in the Odyssey or the Iliad. Homer talks about the wine dark sea, describing it with this imagery, and it might not be a way that we try to describe or evoke what the sea or the ocean looks like. And there might be some complications with translation there, but that it is a really fascinating thing to consider, how across time people possibly perceive things differently.
I think that's right. It is, of course, harder to study across time than studying many people in the here and now. So that's what we're doing instead.
Yeah. All right. To close out, do you want to tell our viewers where they can find you online? You mentioned you have a website they can check out. Do you have any social media channels they can follow you on?
Sure. So my website is anilseth.com. You'll find information about my book there and also the Perception Census. And I'm on Twitter still at Anil K. Seth, and on Instagram and LinkedIn at Prof. Anil Seth.
All right. Excellent. Anil, thanks so much for joining us. It was a pleasure.
Thank you. It's been a pleasure too.